problem. It's a solve log x minus 5 to the base 5 plus log x minus 6 to the base 5 equals 1. Now, here we can see that the bases are the same. Okay, so as we can see, the bases are the same, then our problem is half solved. Okay, so if the bases are the same, then we can straight away apply the laws of logarithm to simplify this one. Okay, so let's look at how to simplify this particular problem. So because the bases are the same and here they are added, so we have to apply the addition and multiplication law of logarithm, right? So what we do, we take one of the log and the base, okay, then we multiply the values. So here you are going to have x minus 5 multiplying x minus 6, and this should be equal to 1. Okay, this is what the law says. When they are added, you multiply. Okay, and when they are multiplied, you can split them by addition. Right. Good. So over here, you can see we have log of this 5 to be equals to 1. So we can peacefully convert this one to indices, right? So in this case, our base is 5. Okay, our base is 5. And our exponent is 1. Is that not it? Okay. Then we have an answer of x minus 5, x minus 6. Okay, so this has been reduced to quadratic, right? This has reduced to quadratic. So let's expand the factors. So we have 5 here equals to, we have x times x, we have x squared, right? X times minus 6, minus 6x, hope you can see that. We are done with the first one. Let's go to the second one. Minus 5 times x.
Minus 5x.
Minus 5x. Minus 5 times minus 6.
Plus 10.
Plus 30. Okay. So we can rearrange them nicely, okay? So in this case, we are going to have x squared minus, so over here we have minus 6x minus 5x is going to give us
minus 11x.
Minus 11x. Then this 5 is going right. So we have plus 30 minus 5 equals
0.
So at the end of the day, x squared minus 11x
plus 25
equals 0. Good. So we solve this one using quadratic approach. So you can use what? Either factorization, right? Or completion of squares, then quadratic formula, right? You can use any of them. So let's try and use a factorization over here. So we have 25 sitting here. We have minus 5, minus 11. So we need two factors, right? When we multiply, we should be getting 25. When we add, we should get minus 11. And what are these two factors? So this is what we have. X squared minus 11x plus 25 equals 0. Okay. So here you can see that using factorization will be a problem, right? We're getting two numbers. When you multiply, you get 25. And when you add, you should get negative 11. It will be a little bit problem, right? So let's try and use completing of squares, right? Let's use completion of squares. So what do? With the completion of squares, we all know that the first thing for you to do is to send a constant to the other side of the equation, right? Send a constant to the other side of the equation. So we have x squared minus 11x equals minus 25. So this is the first step. You send the constant to the other side of the equation. So what we do again, we take the coefficient of x Okay? You take the coefficient of x, then you divide it by 2. You take the coefficient of x over here, the coefficient of x is what? Minus 11. So we divide it by 2, divide it by 2, square your results, and add it to what? Both sides of the equation. So over here, we are going to have x squared minus 11x. So we are going to have plus minus 11 on 2, right? All squared. So you take coefficient of x divided by 2, square your results, and add it to both sides of the equation. And this one should be equal to minus 25 plus minus 11 on 2
All squared.
all squared. That's what we have. Now with this one, you can compress it. You can compress it by what? Taking one of each of the squares. So here we have x, okay? Then over here, you can take one of them from there, which is minus 11 on 2, then we square it. This simply means that if you expand this bracket, you are going to get what you have here. The perfect square. So when you expand this bracket, you are going to get this one over here. So when you compress it, this is what you are going to get. And this one should be equal to, let's simplify this side. So you have minus 25 plus, what is minus 11 squared? Minus 11 all squared, okay? Minus 11 all squared.
We have 121 over 4.
121
Over 4.
on 4, okay. Good. Then we can simplify this side further. So we have x minus 11 on 2 all squared, okay? And this should be equal to, now over here, so we have minus 25 plus 121 on 4. Can you simplify it? What do we have? Minus 25 plus 121 on 4.
We have 21 on 4.
21 on
4.
4. Okay, so this one is going to give us 21 on 4. Okay, good. So at this point, what do? We send the square to the other side. We send the square to the other side. When the square crosses the equation, it becomes what? Square root, right? So we send the square to the other side by taking square root of both sides. Let's put it in that way. By taking square root of both sides. So you take square root of both sides, we are going to have x minus 11 on 2 equals plus or minus
21 on 4.
square root of
Yes, 21.
21 on 4. Right? So this one is 1. So that's what we have. At this point, you can move, because we are looking for x, you can move minus 11 on 2 to join the others. So we are going to have x to be equals to 11 on 2 plus or minus square root of 21. We can find the square root of 4, which is what? 2, right?
Yeah.
So we have square root of 21 on 2. So our x1 over here will be equals to 11 on 2 plus root of 21 on 2. Or our x2 equals to 11 on 2 minus root of 21 on 2. Now you can see that over here, 2 is here, 2 is here. Right? Just like what? Like fraction. Can you see that? So when the denominators are the same, we can add or subtract the numerators, then we take one of the denominators. I hope you remember. So here this is going to give us what? 11 plus root 21 all out of what? 2. You can simplify it like this. Or over here we are going to have 11 minus root 21 all on 2. So maybe you can find this one in decimals. Or better still, you can bring half out, then you leave this one in bracket, okay? You can bring half out. You see that? In that case, you are going to have x1 to be equal to 1 on 2, open bracket, 11 plus root 21. You see that? Our x2 to be equals to 1 on 2, 11 minus root 20. Okay. So that's what we have, and this x1, x2 from this question given. Okay, from this question, x1, x2. Okay.